Fortran, formula translation. Fortran, developed in 1957 by IBM, was designed to make programming more accessible for scientists and engineers. Before Fortran, programming was done in assembly language, which was tedious and error-prone. Fortran introduced a more human-readable syntax and was optimized for numerical and scientific computing. It allowed complex mathematical formulas to be expressed easily, making it revolutionary for tasks like simulations, engineering calculations, and scientific research. Fortran's efficiency and ability to handle large computations quickly made it a staple in fields requiring heavy numerical analysis, and it's still used today in high-performance computing applications. Lisp processing. Lisp, created in 1958 by John McCarthy, was one of the earliest programming languages, designed primarily for artificial intelligence research. It introduced many concepts that influenced later languages, such as tree data structures, automatic storage management, dynamic typing, and the self-hosting compiler. Lisp's flexibility with symbolic computation made it ideal for AI development, natural language processing, and other research areas. Its unique syntax, based on nested parentheses, allows for powerful macros and metaprogramming, which means programs can manipulate themselves. This feature made Lisp a favorite among AI researchers and developers who needed a language that could evolve with their ideas. COBOL, Common Business-Oriented Language. COBOL, developed in 1959 by a committee led by Grace Hopper, was designed for business data processing. It aimed to provide a language that could be understood by non-programmers, using English-like syntax for readability. COBOL excels in processing large volumes of data, making it ideal for applications in finance, government, and administrative systems. It was created to be portable across different computer systems, ensuring that business applications could run on various hardware without significant modification. COBOL's focus on data handling and its widespread adoption in business environments have made it one of the longest-lasting programming languages still in use today. BASIC, Beginner's All-Purpose Symbolic Instruction Code. BASIC, created in 1964 by John Kameny and Thomas Kurtz, was designed to make programming accessible to students and beginners. It emphasized simplicity and ease of use, allowing users to write code without needing extensive knowledge of computer hardware. BASIC's straightforward syntax and interactive mode enabled quick learning and immediate feedback, which made it popular in educational settings and early personal computers. The language played a crucial role in introducing programming to a broader audience and inspired many future programmers. Various dialects of BASIC, such as Microsoft's Visual Basic, continued to evolve and influence modern programming. Simula, developed in 1967 by Ole Johan Dahl and Kristen Nygaard, is considered the first object-oriented programming language. It was designed for simulation tasks, allowing programmers to create models of complex systems using objects that represent real-world entities. Simula introduced concepts such as classes, objects, inheritance, and polymorphism, which became fundamental in later object-oriented languages like C++ and Java. The language was primarily used in simulations, such as industrial processes, traffic systems, and communication networks, providing a powerful tool for modeling and analyzing dynamic systems. B, developed in 1969 by Ken Thompson and Dennis Ritchie at Bell Labs, was a precursor to the C programming language. It was designed for system programming and was used to create early versions of the Unix operating system. B provided a simplified syntax for machine-independent programming, allowing code to be more portable across different hardware. However, its limitations in handling data types and structures led to the development of C, which offered more features and better performance. Despite its brief lifespan, B played a crucial role in the evolution of programming languages and the development of Unix. Pascal, created in 1970 by Nicholas Wirth, was designed to encourage good programming practices and structured programming techniques. It was intended for teaching programming and became popular in academia for its clarity and simplicity. Pascal's strong typing and clear syntax made it an excellent language for learning programming concepts and developing reliable software. It was widely used in education, software development, and early Apple computers. Turbo Pascal, an integrated development environment, IDE, developed by Borland, further popularized the language by providing an easy-to-use platform for writing and debugging Pascal programs. C, developed in 1972 by Dennis Ritchie at Bell Labs, was designed for system programming and operating system development. It provided low-level access to memory and hardware while maintaining high-level programming constructs. C's efficiency, portability, and versatility made it a popular choice for developing operating systems, compilers, and embedded systems. Its syntax influenced many later languages, including C++, C#, and Java. The Unix operating system was one of the first major projects written in C, showcasing its capabilities and solidifying its place as a foundational language in computer science. Prolog, programming in logic. Prolog, developed in 1972 by Alon Kolmar-Auer and Robert Kowalski, is a logic programming language used primarily in artificial intelligence and computational linguistics. It was designed to express logic in a formal way, allowing programs to be written as a set of logical relations. Prolog's strength lies in its ability to handle symbolic reasoning and perform automated theorem proving. It is widely used in expert systems, natural language processing, and knowledge representation. Prolog's declarative nature, where the logic of computation is separated from its control flow, distinguishes it from imperative programming languages. SQL, structured query language. SQL, developed in 1974 by IBM, is a domain-specific language used for managing and manipulating relational databases. It provides a standardized way to query, update, and manage data stored in a database. SQL's declarative syntax allows users to specify what data they want without detailing how to retrieve it, making database interactions more intuitive. It became the standard language for relational database management systems, RDBMS, and is essential for database administrators, data analysts, and developers working with data-driven applications. SQL's ability to handle complex queries and large datasets has made it a cornerstone of modern data management. ML, meta-language. ML, developed in 1978 by Robin Milner and others at the University of Edinburgh, is a functional programming language known for its strong typing and type inference capabilities. It was designed for implementing proof tactics in the LCF theorem prover, making it well suited for formal methods and verification. ML introduced features like pattern matching, garbage collection, and polymorphic types, influencing many later functional languages. Its emphasis on immutability and mathematical functions makes ML a powerful tool for symbolic computation, algorithm development, and academic research in computer science. Ada. Ada, developed in 1983 by the U.S. Department of Defense, was designed for large, long-lived applications where reliability and maintainability are critical. It was named after Ada Lovelace, the first computer programmer. Ada's strong typing, modularity, and support for concurrent programming made it ideal for real-time systems, embedded systems, and defense applications. The language emphasizes safety and reliability, with features that prevent common programming errors and promote secure coding practices. Ada is used in various critical systems, including avionics, railways, and medical devices, where software correctness is paramount. C++. C++, developed in 1983 by Bjarne Stroustrup at Bell Labs, is an extension of the C programming language with object-oriented features. It was designed to provide the performance and efficiency of C while adding abstractions for better code organization and reuse. C++ introduced classes, inheritance, polymorphism, and templates, enabling developers to create complex software systems with reusable components. Its versatility and performance make it a popular choice for systems programming, game development, real-time simulations, and high-performance applications. C++ remains one of the most widely used programming languages due to its balance of low-level control and high-level abstractions. MATLAB. MATLAB, developed in 1984 by MathWorks, is a high-level programming language and environment for numerical computing, data analysis, and visualization. It was designed for engineers and scientists to perform complex mathematical calculations, model systems, and visualize data easily. MATLAB's built-in functions and toolboxes support a wide range of applications, including signal processing, image analysis, machine learning, and control systems. Its interactive environment and powerful plotting capabilities make it a favorite tool in academia, research, and industry for prototyping algorithms and analyzing data. Eiffel. Eiffel, created in 1985 by Bertrand Meyer, is an object-oriented programming language designed to support software engineering principles and produce reliable, maintainable software. It emphasizes design by contract, a methodology that specifies the obligations and benefits of software components, ensuring correctness and robustness. Eiffel's clean syntax and strong typing system make it suitable for large-scale software development. It has been used in various domains, including finance, telecommunications, and aerospace, where software quality and reliability are crucial. Eiffel's influence can be seen in other languages that adopt its design principles. Objective-C. Objective-C, developed in 1986 by Brad Cox and Tom Love, is an extension of the C programming language with object-oriented features. It was designed to add Smalltalk-style messaging to C, allowing for dynamic runtime behavior and flexible code reuse. Objective-C became the primary language for developing Mac OS and iOS applications after Apple adopted it for their operating systems. Its blend of C's performance and Smalltalk's object-oriented capabilities made it a powerful tool for creating user interfaces and handling complex software architectures. Despite being largely replaced by Swift, Objective-C remains important in maintaining and updating existing Apple applications. Perl. Perl, developed in 1987 by Larry Wall, is a high-level, interpreted programming language designed for text processing and system administration tasks. It combines features from various programming languages, making it versatile and powerful for a wide range of applications. Perl's strong support for regular expressions and text manipulation made it a popular choice for web development, scripting, and network programming. Its motto, "There's more than one way to do it," reflects Perl's flexibility and adaptability, allowing developers to solve problems creatively. Perl's extensive library of modules and community support have kept it relevant despite the rise of newer languages. Python. Python, created in 1991 by Guido van Rossum, is a high-level, interpreted programming language known for its simplicity and readability. It was designed to emphasize code readability and reduce the cost of program maintenance. Python's clear and concise syntax makes it easy to learn and use, making it a popular choice for beginners and experienced developers alike. It supports multiple programming paradigms, including procedural, object-oriented, and functional programming. Python's extensive standard library and large ecosystem of third-party packages make it suitable for web development, data analysis, artificial intelligence, scientific computing, and more. Visual Basic. Visual Basic, developed by Microsoft in 1991, is an event-driven programming language and integrated development environment, IDE, designed for building Windows applications. It was created to simplify application development with a user-friendly interface and drag-and-drop components. Visual Basic's ease of use and rapid development capabilities made it popular for creating business applications, prototypes, and educational tools. It allowed developers to create graphical user interfaces, GUIs, and automate tasks quickly. Although it has been largely replaced by Visual Basic.NET, Visual Basic remains an important language for maintaining legacy Windows applications. Ruby. Ruby, created in 1993 by Yukihiro Matsumoto, is a high-level, interpreted programming language designed to be simple and productive. It was influenced by Perl, Smalltalk, and Lisp, combining their best features to create a language focused on developer happiness and ease of use. Ruby's clean syntax and dynamic typing make it easy to write and read code. It supports multiple programming paradigms, including object-oriented, functional, and procedural programming. Ruby on Rails, a popular web framework built with Ruby, revolutionized web development by promoting convention over configuration and rapid prototyping. Java. Java, developed by Sun Microsystems in 1995, is a high-level, object-oriented programming language designed for portability and performance. It was created to write programs that could run on any device with the Java Virtual Machine, JVM, making it platform-independent. Java's write once, run anywhere philosophy allowed developers to create applications that could run on various operating systems without modification. Its strong typing, automatic memory management, and rich standard library made it suitable for large-scale enterprise applications, web development, and mobile development. Java remains one of the most widely used programming languages in the world. JavaScript. JavaScript, developed in 1995 by Brendan Eich, is a high-level, interpreted programming language primarily used for web development. It was created to make web pages interactive and dynamic, running directly in the browser. JavaScript's versatility and ease of integration with HTML and CSS made it the backbone of modern web development. It supports event-driven, functional, and imperative programming styles, allowing developers to create complex web applications, animations, and user interfaces. With the advent of Node.js, JavaScript extended its reach to server-side development, making it a full-stack language. PHP, Hypertext Preprocessor. PHP, created in 1995 by Rasmus Lerter, is a server-side scripting language designed for web development. It was initially developed to manage web content and has evolved into a powerful language for building dynamic web applications. PHP's integration with HTML, ease of use, and wide support from web hosting providers made it popular for creating websites and web services. It powers many content management systems, such as WordPress, and is used by major websites like Facebook and Wikipedia. PHP's extensive library of functions and strong community support continue to make it a popular choice for web developers. Delphi. Delphi, developed in 1995 by Borland, is a rapid application development, RAD, tool and programming language for creating Windows applications. It uses the Object Pascal language and provides a visual design environment for building user interfaces quickly. Delphi's combination of a powerful language, an easy-to-use IDE, and a rich component library made it popular for desktop application development. It allowed developers to create complex applications with minimal coding, accelerating the development process. Delphi has evolved to support cross-platform development, enabling the creation of applications for Windows, Mac OS, iOS, and Android. R. Developed in 1996 by Rossi Haka and Robert Gentleman, is a programming language and environment for statistical computing and graphics. It was designed for data analysis, statistical modeling, and visualization. R's extensive library of packages and powerful data manipulation capabilities make it a favorite tool among statisticians, data scientists, and researchers. It provides a wide range of statistical and graphical techniques, including linear and nonlinear modeling, time series analysis, and machine learning. R's open source nature and strong community support have contributed to its widespread adoption in academia and industry. Lua, developed in 1993 by Roberto Ierosalimsky, Luis Enrique de Figueredo, and Waldemar Seals, is a lightweight, high-level scripting language designed for embedded systems and game development. It was created to be simple, efficient, and easily integrated with other languages. Lua's small footprint and fast execution make it ideal for use in applications with limited resources, such as video games, embedded systems, and real-time simulations. Its flexible syntax and powerful metaprogramming capabilities allow developers to extend and customize the language to suit their needs. Lua's popularity in game development is exemplified by its use in major game engines like Unity and Roblox. D, developed in 1999 by Walter Bright, is a systems programming language designed to combine the performance of C and C++ with the productivity of modern languages. It offers a high level of abstraction, strong typing, and a garbage collector, making it easier to write reliable and maintainable code. D's syntax and features are inspired by C++, but it simplifies many aspects of the language, such as memory management and template programming. D is suitable for a wide range of applications, from system programming and game development to web applications and scientific computing. C#, developed by Microsoft in 2000, is a modern, object-oriented programming language designed for building a wide range of applications on the .NET framework. It was created to combine the power and performance of C++ with the simplicity and productivity of Visual Basic. C# supports multiple programming paradigms, including imperative, declarative, and functional programming. Its strong typing, automatic memory management, and extensive standard library make it suitable for desktop, web, mobile, and cloud applications. C#'s integration with the .NET ecosystem and support for modern development practices have made it a popular choice among developers. F#, developed by Microsoft in 2001, is a functional-first programming language designed for .NET. It was created to provide a concise and expressive syntax for functional programming while also supporting object-oriented and imperative programming styles. F#'s strong type inference, pattern matching, and immutability make it ideal for data analysis, financial modeling, and scientific computing. It encourages a declarative programming style, reducing the likelihood of bugs and making code easier to understand and maintain. F#'s integration with the .NET ecosystem allows developers to leverage existing libraries and tools, making it a powerful tool for various applications. Go, developed by Google in 2009, is a statically typed, compiled programming language designed for simplicity, efficiency, and scalability. It was created to address the shortcomings of other languages in modern software development, such as slow compilation times and complex dependency management. Go's clean syntax, fast compilation, and built-in concurrency support make it ideal for developing web servers, network tools, and cloud services. Its emphasis on simplicity and performance has made it a popular choice for building scalable and reliable software systems. Go's strong standard library and growing ecosystem of third-party packages further enhance its capabilities. Groovy, developed in 2003 by James Strachan and Bob McWhorter, is a dynamic, object-oriented programming language for the Java platform. It was created to provide a more flexible and expressive syntax for Java developers, enabling them to write concise and readable code. Groovy's seamless integration with Java allows developers to use existing Java libraries and frameworks while benefiting from Groovy's dynamic features. It supports both static and dynamic typing, making it versatile for various use cases, from scripting and testing to building complex applications. Groovy's popularity is reflected in its use in frameworks like Rails and Gradle. Scala, developed in 2003 by Martin Edersky, is a hybrid functional and object-oriented programming language designed to address the limitations of Java. It was created to provide a concise and expressive syntax while maintaining compatibility with Java. Scala's support for immutable data structures, pattern matching, and higher-order functions makes it ideal for functional programming. It also supports object-oriented programming, allowing developers to build complex software systems with reusable components. Scala's interoperability with Java and its powerful features have made it a popular choice for data processing, distributed computing, and web development. Rust, developed by Mozilla in 2010, is a systems programming language designed for safety, concurrency, and performance. It was created to address the challenges of writing reliable and efficient low-level code, such as memory safety and concurrency issues. Rust's ownership system and strict compile time checks prevent common programming errors like null pointer dereferenking and data races. Its performance is comparable to C and C++, making it suitable for systems programming, game development, and embedded systems. Rust's growing popularity is reflected in its adoption by major companies and projects that require safe and efficient code. Clojure. Clojure, developed by Rich Hickey in 2007, is a modern, functional programming language for the Java platform. It was created to provide a dynamic and expressive syntax for concurrent programming while leveraging the strengths of the JVM. Clojure's emphasis on immutability and functional programming makes it ideal for building robust and scalable software systems. Its seamless integration with Java allows developers to use existing Java libraries and tools, while Clojure's rich set of data structures and concurrency primitives make it a powerful tool for data processing and distributed computing. Julia. Julia, developed in 2010 by Jeff Bezanson, Stefan Karpinski, Viral Shot, and Alan Edelman, is a high-level, high-performance programming language designed for technical computing. It was created to address the need for a language that combines the ease of use of Python with the performance of C. Julia's just-in-time, JIT, compilation, multiple dispatch, and rich mathematical libraries make it ideal for numerical analysis, scientific computing, and machine learning. Its syntax is simple and expressive, allowing for rapid prototyping and exploration of complex algorithms. Julia's growing ecosystem and active community have contributed to its adoption in academia and industry. Kotlin. Kotlin, developed by JetBrains in 2011, is a modern, statically typed programming language for the Java Virtual Machine, JVM, and Android development. It was created to improve upon Java by providing a more concise and expressive syntax, null safety, and enhanced type inference. Kotlin's interoperability with Java allows developers to use existing Java libraries and frameworks while benefiting from Kotlin's modern features. Its simplicity and readability make it a popular choice for building Android applications, server-side applications, and web development. Kotlin's adoption by Google as a first-class language for Android development has further boosted its popularity. Swift. Swift, developed by Apple in 2014, is a modern, statically typed programming language for iOS, macOS, watchOS, and tvOS development. It was created to provide a safer, faster, and more expressive alternative to Objective-C. Swift's syntax is clean and concise, making it easy to read and write. It offers features like optionals, type inference, and memory safety to prevent common programming errors. Swift's performance is comparable to C++, and its interoperability with Objective-C allows developers to integrate it with existing code bases. Swift's growing popularity is reflected in its widespread use for building mobile and desktop applications within the Apple ecosystem. TypeScript. TypeScript, developed by Microsoft in 2012, is a statically typed superset of JavaScript designed to improve the development of large-scale applications. It was created to address the shortcomings of JavaScript, such as lack of type safety and scalability issues. TypeScript's strong typing, classes, and interfaces make it easier to write and maintain complex code. Its compatibility with JavaScript allows developers to gradually adopt TypeScript in existing projects. TypeScript's popularity has grown significantly with the rise of frameworks like Angular, which leverage its features for building robust and maintainable web applications. Zig. Zig, developed in 2020 by Andrew Kelly, is a low-level programming language designed for systems programming and performance-critical applications. It was created to provide better safety and simplicity than C while maintaining similar performance characteristics. Zig's focus on explicit memory management, compile-time code execution, and minimal runtime make it suitable for embedded systems, game development, and high-performance computing. Its simple syntax and powerful tooling, such as the built-in package manager and cross-compilation support, make Zig an attractive choice for developers looking to write efficient and reliable low-level code. Carbon. Carbon, introduced by Google in 2022, is an experimental programming language designed to be a successor to C++ with modern features and improved safety. It aims to provide a smooth transition for C++ developers by maintaining compatibility with existing C++ code while introducing new syntax and features for better code readability and maintainability. Carbon's focus on performance, safety, and ease of use makes it a promising candidate for systems programming, game development, and other performance-critical applications. Its development is still in the early stages, but it aims to address the challenges and limitations of C++ while building on its strengths. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content. Let us know your favorite programming language in the comments. See you next time.